In this lesson, we're going to look at multiplying radicals. And for this lesson, the topic areas we're going to consider are understanding the multiplication rules, the steps in multiplying radicals, applying the distributive property of multiplication, and then using the for method for radical expressions. Generally, the rule states that if you have the same degree of a radical, if the degree of the radicals are the same, you can multiply the radicands together. So that's what this is showing right here. So if we want to apply that rule here, so in this case, our degree is b. And so now that means that because our degree is b, so we can multiply 2x and 4x together. So this is going to give us degree b and then 8x squared. Let's look at this. In this case, we have a degree of 3 here and a degree of 2. What this means is that we cannot multiply these radicals together because they have varying degrees. So this is not possible. Now let's look at applying the let's look at the steps in multiplying the radicals. The first thing we're going to do is we're going to look at the degrees of the radicals. If the degrees are the same, then we can multiply the radicands. In this case, the degrees are the same. So we have 2 square root of 3 times 3, which is 2 square root of 9, which is 2 times 3, which is 6. Now, here also our degrees are the same. We have the same degrees. So we have 5 square root of 6 times 8, which is 5 square root of 48. Now we're going to simplify 48 using our factor tree method. We're using 2 and 24, 2 and 12, 2 and 6, and then 2 and 3. So we have a pair of 2's here, another pair right here, and then we have 3 that is alone. So this is going to be 5 times 4 square root of 3, which is equal to 20 square root of 3. Now, let's look at this one here. We have a degree 3 here, we have a degree 3, and then we have a degree 2 here. So the only ones we can actually multiply together are the ones with the degree of 3. So this is going to give us degree of 3, 9 times 3, multiplied by square root of 12. So let's go ahead and simplify. This is the cube root of 27 multiplied by the square root of 12. So we're going to simplify 27. We have 3 and 9, and then 9 breaks up into 3 and 3. So we have a cube root of 3. We had the cube root of 27 is equal to 3. Now let's look at 12. 2 and 6, 2 and 3. So this is going to give us, we have a group of 2 here, so this is going to give us 2 square root of 3. So now this becomes 3 times 2 is 6. This is 6 square root of 3. Now we're just going to use the distributive property. So that means that we're going to multiply every term in the parentheses by the number outside the parentheses. In this case, that is 2. So this is going to give us 2 square root of 3 plus 2 square root of 6. And you can simplify further because the number under the square root sign or the radicand are different, even though they share the same degree. Now, let's look at this. We have two different approaches we can take with this. We can simplify what's in the parentheses before we distribute, or we can distribute and then simplify later. Let's simplify first. So 8, we have 2 and 4, and 4 breaks down to 2 and 2. 18, we have 2 and 9. 9 breaks up to 3 and 3. So we're going to rewrite the whole expression. So this is 3, and then now we replace square root of 8 with 2 square root of 2, and we replace square root of 18 with 3 square root of 2. Now you can see here that we can actually add them together because they have the same radical. So this is 3, and then 2 plus 3 is 5 square root of 2, which is going to end up as 15 square root of 2. Going to apply the same method, and looks like in this case the number or the term we're going to distribute into the parentheses is also a radical. So for this method, we're going to distribute first and simplify later. So this is going to be square root of 6 times 8 plus square root of 6 times 18. So this is square root of 48 plus square root of 108. Let's simplify. 48 is 2 and 24, 2 and 12, 2 and 6, 2 and 3. Let's look at 108. We have 2 and 54, 2 and 27, 3 and 9, 3 and 3. So we replace 48. So for 48 we have two groups of 2's. So we're going to multiply 2 times 2. That gives us 4 square root of 3 plus square root of 108. 108 we have a group of 2, a group of 3. So we have 6 square root of 3. So now we have the same common terms for the radical, so we can just add the whole number on the left of the radical. So that's going to give us 4 plus 6 square root of 3, which is going to give us 10 square root of 3. We're going to apply the same method here again. So it's going to give us square root of 5 times 15 plus square root of 5 times 20. So we have a square root of 75 plus a square root of 100. 75, 3 and 25. 25 is 5 and 5. And then for 100, 2 and 50, 2 and 25, 5 and 5. So the square root of 75 is going to give us, because we have a group of 5's, is going to give us 5 square root of 3 plus a group of 2, a group of 5. 10. Now we're going to use the FOIL method. Remember, FOIL stands for. So for FOIL, FOIL means F stands for first terms in the expression. O stands for the outer terms. I stands for inner, and then L stands for last. So let's apply that. The first terms are 2 and square root of 3. The outer terms are 2 and square root of 5. The inner terms are, so the inner terms are square root of 3 and square root of 3, and the last terms are square root of 3 and square root of 5. So let's simplify. So this is 2 square root of 3 plus 2 square root of 5 plus 3 plus square root of 15. Nothing can be simplified, so that's using the FOIL method with radicals. Now let's take a stab at this one. So we have square root of 8 multiplied by square root of 12. The outer terms are square root of 8 multiplied by negative square root of 27. The inner terms are square root of 6 multiplied by square root of 12. And the last terms are square root of 6 multiplied by the square root of the negative square root of 27. So this is going to give us the square root of 96 plus minus square root of 216 plus the square root of 72 minus the square root of 162. So let's make this quick. With 96, we have 2 and 48, we have 2 and 24, 2 and 12, 2 and 6, 2 and 3. So 96 we replace that with, so we have a pair here and a pair here, and we have 6 left over. So this is going to be 4 square root of 6. 216, 2 and 108, 2 and 54, 2 and 27, 3 and 9, 3 and 3. So we have a pair of 2's here, we have a pair of 3's here, and then we have 6 left over. So this is going to give you 6 square root of 6. Let's look at 72. 2, 36. We can stop here and say this is going to be, it's going to be 6 square root of 2. And then 162. Let's decompose. We have 2 and 81. So this is going to give us 9 square root of 2. So 4 minus 6, negative 2 square root of 6. 6 minus 9, negative 3 square root of 2. Let's do that for this again. So we have square root of 6 multiplied by square root of 15 minus 2 square root of 8 times minus 3 square root of 18. Then minus 2 square root of 8 times square root of 15, and then we have plus 6 plus square root of 6 minus times minus 3 square root of 18. So this is square root of 90. This are multiplied together, this are multiplied together, and these are multiplied together. So 2 square root of 8, so we have plus 6 square root of 144 minus 2 square root of 120 minus 3 square root of 108. So 90 is 9 times 10, so that's going to give us 3 square root of 10 plus 6 times 12 minus 2. So 120 is 4 square root of 15 minus 3 times 6 square root of 3. So this is 3 square root of 10 plus 72 minus 8 square root of 15 minus 18 square root of 3. And finally, we're going to apply the distributive property. And so we're going to pick a term. I'm going to use this. I'm going to distribute this square root of 15 minus 3 square root of 6. I'm going to distribute that into square root of 5 minus 2 square root of 6 minus 4 square root of 7. So we have square root of 15 square root of 5 minus 2 square root of 6 minus 4 square root of 7 minus 3 square root of 6 distributed into square root of 5 minus 2 square root of 6 minus 4 square root of 7. So this is going to give us square root of 75 minus 2 square root of 90 minus 4 square root of 105 minus 3 square root of 30 plus 6 square root of 6 plus 12 square root of 42. So now let's simplify each of these terms. This is going to give us 5 square root of 3 minus 2 times 3 square root of 10 minus 4 square root of 105 minus 3 square root of 30 plus 6 square root of 6 plus 12 square root of 42. So now let's simplify. This is 5 square root of 3 minus 6 square root of 10 minus 4 square root of 105 minus 3 square root of 30 plus 6 square root of 6 plus 12 square root of 42. There are no terms that we can simplify or combine or group together. So this is the solution to this problem.